So I've got a piece of aluminum in my chuck. This is a 3-jaw chuck. There are many different types of chucks, of course. I'm going to refer to the textbook and ask you guys to research them. There are 3-jaw, 4-jaw, 2-jaw. My goodness, I think there's a 12-jaw chuck available. There's face plates, there's all kinds of tools, and I need you to understand the tools that are involved in doing lathe work, all right? So this is part of your curriculum, and it's why we've got that textbook. Right now, I can do facing and turning using this threading tool. It's just a 60-degree angle, which is your standard angle for most threads. When I come in and I try to face, I'm going to find that it's difficult for me to get the cutting tip to be on the face of my part. I need to face this part. How am I going to do it? If I loosen my quick release here and I move my tool holder into this position, I need to switch this around to the other side here. I'm going to grab my Allen wrenches, loosen off on this side, take my cutter out, move it over to the other side. Now you can see that it's going to be able to reach here pretty easy, right? There shouldn't be any trouble at all. So I'm just going to tighten this down in. You should each have one of these tools that is an Allen key set in your tool box. I'm going to set my feed rate to be fairly slow and my RPMs to be fairly slow. You guys remembered the formula for RPMs, I'm sure, right? It was cutting speed times 4 over D or something silly like that. There we go. My cutting tool can't go anywhere. Oh my goodness, there's a whole cluster of tools here that shouldn't be. This tool is called a wrench. This wrench is here. And it lets me loosen my tool post so that I can pivot it. I need to set this tool post so that it's on this piece right here. It's the slide mechanism on our compound rest. I want to tighten it, but not too tight, just like so it can't go anywhere. And then I put my wrench away so that I can't hurt myself. The next thing, I want to come in and try to find center, make sure I've got enough room to be able to do it. If I need to move in, I can move in here. This is back and forth here. I'm seeing already that my cutting tool is too low. So I want to loosen this off. I want to move my cutting tool up towards center. Tighten down. Move this down so it can't go anywhere on me. Lock it in place. Now I should be able to fire up this machine, but I don't know who was on it last. So I want to make sure that this chuck can't fall off by mistake. On the chuck here in 3 different positions is a locking mechanism. So I take my chuck key, I put it in here, I give it a little turn, a little turn, a little turn, and I'm just making sure that it's not going to come off on me when I speed this thing up. Right now I'm set at 630 RPMs or 900, depending on if it's slow range or fast range. That's inside the door over here. I don't know if you can see it. Can you see that? Right now, we're set at the faster range according to the belt position inside. I just checked the belt and the motor and the sheaves that the belt goes on, and it's going to try to run at 900 RPMs. For aluminum, that's going to be just fine. So I need you to focus down here on my aluminum piece again. And I should be able to fire this bad boy up. I have my safety glasses on and my work boots. Everything's looking good. Let's check the direction of rotation. So I see that this is spinning counterclockwise or anti-clockwise right now. If I come in and I touch on this side, it's going to rub that carbide tool right off and ruin it. I don't want to touch off on this side. I want to touch off over here towards me because that's the standard place to touch off. And I'm going to do that right now, and I'm not going to use a feed at all. I'm going to hand feed it in using the cross slide. Okay, so I'm going to start this bad boy up right now. I'm going to come in and touch. going to move it out. I'm going to take a cut. Now if we look at the surface finish here, it's shiny, but I can feel a little bit of roughness. Is that a fine cut or is that a roughing cut? I think it's kind of in between right now, but since I wasn't using a feed rate, I was just going by hand, I'm going to say that it's just an adequate cut to face and make this flat so that I can set a center hole location and put a center hole in here. All right, so the next process that I'm going to do on this hammer handle that we're seeing is I'm going to use a center drill. It's part of your kit too. I'm going to put it in Morse chuck. I'm going to tighten up the chuck so that this is on center. Then I'm going to use this Morse taper in the tailstock. Can you see the tailstock?
Just 1 second.
Right here. Now if I try to engage the tailstock right now, my tool's in the way, so I need to back it out a little bit. When I try to push this in with just a little bit of force, it locks into place because that Morse taper is a self-locking taper. If you don't engage it with a little bit of emphasis, you're going to find that it tries to spin on you. That's not a good thing when you're trying to take a cut. This little drill tip needs to be sharp, so I need to find a key that fits in here so I can turn it and make it tight. And then what I'm going to do is I'm going to move this over until it's at my part over here, and I'm going to set a hole that acts as support for one of these two tools. This is a live center and this is a dead center. Now can you think of what would happen with this dead center if I tried to push it into this piece of aluminum with no lubrication? This piece is hardened steel. It might even have a carbide insert in it. This aluminum is something that piles up really easy. It gets hot really easy. Without lubrication, this hole is going to get big very, very quickly, and it's going to transfer aluminum onto this part, and it's going to make a mess of my part. So don't use these unless your teacher tells you to. It's for the knurling operation, and use lots and lots of grease when you do, so that we don't get that interaction, the relationship between friction and the lubrication. All right, we want to make sure that that doesn't happen. So we're going to use this one instead that has bearings in it, and it spins. You can see that it spins. So when we put this in, it's going to be able to engage into the hole that we're creating right now, and this spins with your part and doesn't cause that friction. All right, so I'm going to tighten this little center drill into place by pulling on this handle. A lot of people try pushing it instead. Here, and when you do, it changes the relationship between the gear teeth. If we pull from here, it causes this mechanism to tighten up. When you tighten, it doesn't try to slip on you. Have you ever used a hand drill where you try to tighten that and it slips on you? It's because you're pushing instead of pulling. You learned something new today. Now that this is tight and in place, I should be able to move this in until it's almost touching. I should be able to hit a locking mechanism right here so that it doesn't try to slide on me when I'm drilling. When I go to touch off, I should be able to see that it's very, very close to center here. If it's not on center, you have a problem with your tailstock and it needs to be adjusted. Talk to your technician or teacher, or go to your textbook and learn how to set that, but that's another story. We'll get at that later. Right now, we need to talk about cutting speed times 4/d again, because that is 1/8 of an inch, the decimal 125. We need to make sure that we're spinning for aluminum at a cutting speed of 400 times 4, 1600, divided by 0.125 for the proper RPM for that cutting tip. You'll notice that there's a little bit of a taper on my drill. I want to use some of that taper right here for support for my centers. Now this is the dead center, but we're going to use a live center. This angle here is the same angle as that one right there. So in order to provide support, I want to go at least halfway up this taper. Watch what I'm doing, you'll understand. so you can see the angle that I've developed here. But I don't know if you noticed, while I was peck drilling in order to remove chips, this whole piece slid backwards in the chuck a little bit. Somebody didn't tighten up the chuck quite enough for the cutting pressure that's going on. Now it's tight enough to be able to do this job. The unfortunate thing is, well, now we have to reposition for another operation and I have to loosen it again.